All right, so this is our second video on volume, and right now we're going to go ahead and start talking about how to find the volume of a pyramid. So our last video discussed the volume of a prism, and then today you're going to see we've got some different pyramids here. We're going to learn how to find the volume of those. So let's talk about what a pyramid is first. You can think of the pyramids in Egypt, lots of different, real world examples of those, but basically a pyramid has a polygon base, which basically just means it has a shape for a base. It also has triangular faces. So all of the things that are kind of leading up to the common vertex are triangles, and we'll see those in a minute. And then at the very tip top, they have something called a common vertex, which just means all of those faces come to a point. So let's take a look at this picture right here. So the polygon base would be this shaded rectangle. The triangular faces are all of these triangles that are around the sides that are leading up to this common vertex. So right up here, this would be the common vertex. So that's going to be the difference between a pyramid and a prism, because a prism does not have this common vertex. A prism has two bases that are going to have a height in between. So that's going to be a little bit of the difference. The formula is very similar. There's one tiny difference. So the very first thing we're going to do is to write our formula and write it out in words. So V equals, and instead of capital BH, like a prism, there's a 1/3 in there. So the only difference between the formula from a prism to a pyramid is this 1/3. So basically, a pyramid is just 1/3 of the volume of a prism. So let's go ahead and write this out in words. We know V stands for volume. You're going to need 1/3 of capital B, and we're going to write this out again because in our last video we talked about it, but I want to make sure that we understand. Capital B stands for the area of the base. So we need 1/3 of the area of the base times, and then this H right here is the height. So let's talk through what this height is. This height is the height of the pyramid. So it's not the height of the base, it's the height of the actual pyramid. So we'll talk through what that means here in just a second. All right, so let's go ahead and get started here with our first example. So the very first one that we're gonna do is this right here. We're going to name this shape. So just like a prism, pyramids are named by their bases. So I'm gonna go ahead and highlight the base. So this pyramid has a rectangular base, 17 and 32, so that's going to be a rectangle. So this is a rectangular pyramid. Basically just means that the base is in the shape of a rectangle. So the very first thing that we're going to do as we're working this problem, I tell my students every single time, we're going to write the formula, V equals 1/3 capital BH, and then we're going to fill in what we know. So the very first thing that we really probably need to do here, we don't have any information to plug in yet because we need to find capital B. And remember, capital B, just like we wrote up here, was the area of the base. So in this case, it's a pretty easy thing to find. We said our base is a rectangle. The rectangle formula is A equals BH. So to find the area of that base, the base and height of just the yellow rectangle is 17 and 32. In this case, we would not use the 24. The 24 has nothing to do with that rectangular base. The 24 is going to be something different. So 17 times 32, you might have already done that. That's going to be 544, and it is area, so it is feet squared. So at this point, we're going to go ahead and plug in to our volume formula. We need 1/3 we found capital B, which was the area of the base. So we're gonna plug that in. And the height of this pyramid, we follow the common vertex all the way down to the base, and notice it meets at a right angle. So I'm gonna go ahead back up here for just a minute. So the height of the pyramid, it must meet the base at a right angle, which is a 90-degree angle. So that's a really quick way that you can find which one is your height, because if it doesn't meet the base at a right angle, it's not going to be your height. So we're going to use this 24 as our height. Oops, sorry. That's why we got an erasable pen going on here. This is not area, we're working on volume. So volume is going to be 1/3 of 544 times 24. That is going to be 13,056, I believe. And now this is the only thing that's different between finding the volume of a prism and the volume of a pyramid. We need 1/3 of something. So let's talk about finding 1/3. Finding 1/3, there's two ways we can do this, okay? Really, one of the ways that we can do this is to divide by 3, which I would really encourage you to do this way, or we can multiply by the fraction. So that would just be the top times top and bottom times bottom. You're gonna really see me do this division by 3 because it's gonna get us there just a little bit faster. So if I take 13,056 and I divide it by 3, we're gonna be left with 4,352, and this is feet, and because it is volume, it's going to be cubed. So the volume of this rectangular pyramid is going to be 4,352 feet cubed. All right, so let's go ahead and go over to this other example. This one's a little bit different, and hopefully maybe take a look at it, see what the differences are between the one that we just did. So we had a rectangular pyramid. This one, let's highlight the base here. The base here is no longer a rectangle, so this is a triangular pyramid. So the very first thing we're going to do, again, we're going to write our formula. V equals 1/3 capital BH. First thing that we need to do is find the area of the base. So this base is a triangle, which means we're going to use the triangle formula. A equals 1/2 BH. And let's take a look at our yellow highlighted triangular base. The base of the triangle is 12. The height of the triangle has to meet its base at a right angle, which is right here. So that's going to be 10. Notice, I think the most interesting thing about these is the height. So finding this would be the height of the base. This is the height of the whole pyramid. So just be really careful. That's why I like to highlight some things. So now let's go ahead and just multiply through. We've got 1/2 of 120, and I think we might be able to do that one in our head. Half of 120 is 60, and this is going to be inches squared because it is area. So now that we have the area of the base, we can plug it into our volume formula. 1/3, don't forget to drop down your 1/3. That's kind of where a lot of people make a mistake, is instead of, they'll write the formula correctly, but then they'll just forget to bring that 1/3 down. Area of the base, which is capital B, was 60. And now let's talk about the height of this pyramid. Here's the vertex. The height is where it meets the base at a right angle, which is 17. Absolutely gonna be 17. So let's talk about order of operations here. This is all multiplication, which means basically you can do that in whatever order that you want to. So in my mind, I'm gonna go ahead and get rid of this 1/3. So I can take 1/3 of 60 pretty easily. So that gives me 20, and then all I have to do is multiply that times 17. Could you still have done exactly what we did over here and just gone ahead and multiplied those two together? Absolutely. So if you're not really able to see those numbers and you maybe don't know your multiplication facts really well, you can still do it the same way, and we're gonna all get to the same answer at the end. So 20 times 17 is 340, and this is inches cubed. So that would be our final answer for the volume of this figure here. Okay, we've got two more examples to go through. Let's look at this one here on the bottom. A lot of people, if they're trying to name this figure, say that this is a square pyramid. Though it does look like a square pyramid, this side is 22 and this side is 21, so we can't call that a square pyramid. Still gonna call this a rectangular pyramid. Okay, all right, so same process. Hopefully at this point you know exactly what formula we're gonna be writing. V equals 1/3 of capital B times H. We don't know, we're not given the information as to what capital B is in this case. We do know what shape it is though, so we can definitely use that information. It is a rectangle, which is probably one of the easier ones to find. So the base, I would say, is 22 of that rectangle, and the height is 21. So 22 times 21 is gonna give us 462, and that's meters squared. So the area of our base, in this case, we've got 462. So let's bring down our 1/3. For area of the base, we're gonna take this information that we just found. And the height of this pyramid, let's take a look at the common vertex at the top, all the way down to the base and a right angle, and that is 35. So the height of this pyramid is gonna be 35. All right, I don't know if you can take 1/3 of 462 really easily, so we're just gonna go ahead and multiply these two guys out. So I need 1/3, 462 times 35 is 16,170. And then again, to find 1/3 of something, we're gonna go ahead and just divide that by 3. So 16,170 divided by 3 is gonna be 5,390. And because it is volume, it is meters cubed. Okay, all right, one more example. Hopefully this is just practice by now. I would encourage you at this point of the video, if you feel confident, maybe go ahead and pause here, work it out for yourself, and then you can check the work with us here in just a moment. So let's go ahead and highlight the base. Hopefully you can see at this point, this guy is gonna be a triangular pyramid. It does have a triangle for a base. It's a little bit wider than the other one, but it is going to be a triangular pyramid. So our formula, same thing. V equals 1/3 capital B times H. We don't have the area of the base yet, so that's the very first thing that we're gonna do. We're gonna come over here, and our base is a triangle. So the last question that we did, we used the area for a rectangle. This one, we are doing the area of a triangle, so we need to make sure we're using the triangle formula here as we find the area of the base. The base of this triangle, if all we can see is this yellow triangle, that base is 15. And the height of that yellow triangle is 11. It meets this base at a right angle. Okay, all right, so let's go ahead and do some multiplication. 15 times 11 is 165. And then to find half of 165, I would divide that by 2, and that's gonna be 82.5, and this is feet squared. So again, that 82.5 is our capital B. That's our area of the base. Let's go ahead and plug in what we know. 1/3, again, don't forget your fraction. Capital B was 82.5. And the height, again, let's go back with our marker. Our common vertex is right here. All the way down, it meets the base at a right angle. So 19 is gonna be the height of our pyramid. At this point, it's just order of operation. So 1/3, 82.5 times 19, I believe is 1,567.5. And again, to find 1/3, we're just gonna divide by 3. So 1,567 divided by 3 is 522.5. Absolutely gotta look at our units, and it's gonna be feet cubed. Real quick to wrap up, let's just take a look back at our formula. Volume equals 1/3 capital B times H. You need 1/3 of the area of the base times the height. Make sure when you're finding your height, the height of the pyramid, it has to meet the base at a 90-degree angle. Good luck.